Hi everyone, welcome back to my channel. In today's video, I'll show you a Python tool that reads an RT plane and RT structure DICOM files, finds the localization point, and prints the shifts from the point to the plane isocenter. It also shows the patient position pulled from the plane's patient setup sequence. Let's first walk through the core logic. The script mainly does four things. First, it reads isocenters per beam from the RT plane's control points, which is in this section. Second, it finds the point ROIs in the RT structure where the contour geometric type equals point. And it's shown in this section. Third, it picks the localization point either by a name hint like localization or by some keyword heuristic, which is in this section. And lastly, it prints the results in a clean and concise format, as shown here. So now let's run the script. In this demo, the RT plane and RT structure file paths are hard-coded for simplicity, but you can easily adapt it for your own workflow. So here is the output. It first prints out the patient position, and in this case, it's head first supine. Then it finds the isocenter. In this case, all four beams share the same isocenter, so it prints out one row. It also chooses the CT laser point as our localization point, and it also prints its coordinate system. Then it's print out the vector, which is the isocenter minus the localization point, and give us the coordinate system in the patient coordinate, left, posterior, and superior, and gives these numbers. So in this example, the -40, meaning in the patient left, posterior, superior direction, the patient left is positive. So this means the isocenter is to the right of the localization point. And therefore, in order to move the patient to the treatment position, we are moving towards the patient left 40 millimeter. And the same as for the end post direction, as well as for the sup-inf direction. So because we are using the patient coordinate system, this is valid whether the patient is supine or prone. One final note is that if you need couch directions like in, out, left, right, so on and so forth, you will have to transform the LPS vector into the IEC treatment coordinate system, using both the couch angle if there's a couch rotation and patient orientation. That will get more complicated, and we are skipping it here to keep this tool simple and unambiguous. That's it for today's demo. A simple, clear way to report localization to isocenter shifts without sign headaches. If you found this helpful, like, subscribe, and drop your questions in the comments. You can also download the script from the link in the description below. See you next time. Bye.